Taiwan Semiconductor TSM Beginner's Guide. If you have ever used an iPhone, asked a chatbot a question, or played a modern video game, the chip behind it was almost certainly built by one company in Taiwan. Today we are walking through Taiwan's Semiconductor Manufacturing Company, TSMC, the quiet giant that physically makes the brains of most of the world's electronics. This is an educational overview only, not investment advice. So, what does TSM actually do? Here is the simple version. Most chip companies you have heard of, NVIDIA, Apple, AMD, Qualcomm, do not actually build the chips they design. They draw the blueprints and hand them to a contract manufacturer who builds the physical silicon. That contract manufacturer is called a foundry, and TSMC is by far the largest foundry in the world. The technical term is pure-play foundry, which just means TSMC only manufactures chips for other people. It never designs and sells its own competing chips. That neutrality matters, and we will come back to it. TSMC's revenue is sorted by what the chips are used for. The biggest bucket is HPC, high-performance computing, about 61% of revenue. That covers AI accelerators for NVIDIA, AMD, and Broadcom, along with CPUs, GPUs, and FPGAs. In plain English, almost every AI chip behind a chatbot or a data center is made here. Next is smartphones at about 26%, dominated by Apple's A-series and M-series processors plus Qualcomm and MediaTek. After that comes smaller buckets, Internet of Things devices like wearables at 6%, automotive chips for driver assist and electric vehicle power at 4%, and a small consumer electronics slice at 1%. One more dimension worth knowing. Chips are described by node size, 3 nanometer, 5 nanometer, 7 nanometer, and so on. Smaller numbers mean newer, faster, more power-efficient chips that sell for much more money. TSMC is the only company that can build the most advanced nodes at high volume. Today the cutting-edge nodes, 7 nanometer and below, are about 74% of the business, with 3 nanometer alone at 25% of wafer revenue. For scale, the company shipped 15 million wafers in fiscal 2025. So who does TSM compete with, and how does it win? TSMC's main competitors are Samsung Foundry in Korea and Intel in the United States. Both have tried for years to catch up at the leading edge, and both have struggled. TSMC has what investors call a wide moat. A moat is just a competitive advantage that keeps rivals from catching up, and there are 3 reasons for it. First, manufacturing technology leadership. TSMC is roughly 1 to 2 years ahead of Samsung and 2 to 3 years ahead of Intel on process technology. When TSMC introduces a new node, it ramps faster, has better yields, the percentage of chips that come out working, and delivers better performance at lower cost. About 77% of TSMC's revenue comes from this leading edge. Second, the pure-play model. Samsung also makes its own smartphones, and Intel also designs its own CPUs, so they are competitors of the very customers they are trying to win. Apple, NVIDIA, AMD, and Qualcomm can all hand their most sensitive designs to TSMC at the same time without worrying about a rival peaking. And switching foundries is brutally expensive. Qualifying a new manufacturer takes 12 to 18 months and billions in redesign work. That is high switching costs, which is just a fancy way of saying once a customer is in, they basically stay. Third, scale and ecosystem lock-in. TSMC has roughly 60% of the global foundry market and about 90% of leading-edge production. That scale supports more than $6 billion a year in research. On top of that, the entire chip design software and intellectual property ecosystem is optimized for TSMC's process design kits, the templates that teach designers how to lay out a chip for TSMC's factories. More designs on TSMC attract more tool vendors, which attract more designers. That is a network effect, and it makes the moat self-reinforcing. What are the key drivers for the business over the past 5 years? TSMC's revenue more than doubled from roughly $48 billion in fiscal 2020 to about $122 billion in fiscal 2025, a 155% jump in 5 years. Three forces drove it. The first was the rise of AI. HPC grew from about 35% of revenue to 61% as demand for AI accelerator chips exploded. Every node TSMC offers carries higher wafer prices than the one before. 3-nanometer chips sell for roughly 70% more per wafer than 7-nanometer, so the shift toward more advanced chips made each wafer more profitable. Operating margins, profit on every dollar of sales after running costs, expanded from about 42% to 54% as leading-edge fabs stayed full. The second was advanced packaging, specifically CoWoS. CoWoS is a technique for stacking chips on top of each other so they sit very close together inside a single package, essential for AI chips that need to talk to high-bandwidth memory at extreme speeds. NVIDIA's AI accelerators cannot ship without it, and TSMC is essentially the only supplier. CoWoS went from a rounding error 5 years ago to about 8% of revenue in 2025, roughly $10 billion, and it is projected to exceed 10% in 2026. The third is what the company spends on factories. TSMC has been investing $30 to $36 billion a year on capital expenditure, the money it spends building new fabs and buying equipment, and that is rising to $52 to $56 billion in fiscal 2026. That funds the 2-nanometer ramp, new fabs in Arizona, Japan, and Germany, and more CoWoS capacity. The scale of investment is itself a barrier. Only TSMC can spend this much and still earn 60%, plus gross margins. To wrap up, so here is TSMC in one sentence. It is the world's largest contract chip manufacturer, the company that physically builds the most advanced chips for almost every major tech name. With a structural neutrality and technology, lead competitors have spent a decade failing to close. As a learner, the things to watch are the 2-nanometer ramp, the continued build-out of CoWoS advanced packaging, and the geographic expansion into Arizona, Japan, and Germany. Together, those tell you how the next 5 years of AI hardware get built. This was a beginner business overview, educational only, and not investment advice.